So we're going to talk about the categories of tools in Security Onion. Your projects are mostly focused on Splunk, and the more I use these things, the more I'm sticking with that decision. Some people like Security Onion, but I really don't. This stuff is broken, out of date, not updated. It's just, if you want to get something done, you use Splunk. The only reason you'd use this stuff is because you're some kind of open source fanatic and it's a religious mission. Not if you want to actually get the job done. And everybody really does use Splunk. So now some of these other tools people really use, like Wireshark and Bro. Those are really important. A lot of these others are just going to be forgotten in a few years, I really think, and they're already showing signs of it. So, well, anyway, however, the command line tools here are pretty good. And so we'll go through them, you see how they work, but I'd say that the number one most important tool is Splunk, standing above them all. After that is like maybe Bro. Anyway, so here's tools we got. There's data presentation tools. And these are packet analysis tools that will take either live data or get it saved in PCAP format, so it has all the information of live data, and then make some way for you to hunt through it and find interesting things and see what's interesting about it. So you got TCP dump and Tshark. TCP dump is the classical Linux packet sniffer. It's been around forever. Unix, I guess, is JPacket sniffer, and it has the feature to search through packets to some extent. Tshark is the command line version of Wireshark. It comes with Wireshark, and it makes it possible to do everything from the command line, which, as you know, is super important because you might want to script things. The problem with graphical tools is you have to move the mouse and it has to be real human there. They're pretty, but if you have to do like 10,000 similar things or run a cron job every half hour, you can't use a GUI tool. You've got to have a command line tool, and that's what Tshark is. Tshark comes with Dumpcap because Wireshark and Tshark are too smart and too out of control. The cool thing about Wireshark and Tshark is they know everything about every protocol. And there's people inventing new stuff all the time. And the problem with that is that stuff is contributed by just members of the community. It's like Firefox extensions. So a lot of that stuff is not secure. So you don't want to run Tshark or Wireshark on live data because it probably has command injections and buffer overflows and everything else. And even if it doesn't today, next week it does because some clown updated some more protocol dissectors. So what you ought to do is collect the data with some other tool that is stupider, that just records the data, and then analyze the data after it's recorded with these fancy tools to make it pretty. And what they recommend is Dumpcap. Dumpcap is the simple tool to collect data and store it, and then after you've got it, analyze it with Tshark or Wireshark. That's the recommended procedure to be secure. And then there's the Argus raw client we'll go through today. This is like NetFlow. It is a flow monitor. It is not a packet capture tool. Instead of recording every packet, it just records one line for every flow of data, which is much less information. It's sort of like the pen register information. You get to see who talked to who, on what port, for how long, at what time, but not what they said. So this will help you quickly find out who's been talking to the command and control server, who's been going to the forbidden website, things like that. Sometimes that's what you want. But if you needed the entire traffic flow, you're going to need the whole PCAPs. All right, then we got the graphical ones like Wireshark, which is the king. That's not going anywhere. Explico, which doesn't seem to work very well. I think the thing about Explico is all the graphics rely on Flash because they don't work anymore. And the Network Miner, which some people use in forensics. Although my previous experiences with it, I haven't been too impressed either.
Yeah. What do you say, Wireshark's not going anywhere?
Wireshark is really important. Wireshark is huge. Everybody loves it. It's one of the main tools of the business.
Oh, you mean it's not going away?
Yeah. Wireshark is very valuable and deserves it. I even got a certification just in Wireshark. Now, Wireshark is a winner like Splunk. Wireshark and Splunk are going to be here for a long time. And knowing them is going to really help people on the job. These other things, not so much. These other things, I think, are like the prototypes that are being replaced by those other tools.
No iOS on Wireshark.
Yeah, you can, not on iOS. No, on iOS you don't get any of this unless you jailbreak your phone. On iOS you can't even put a sniffer or a firewall or anything, not an unrooted iPad or iPhone, because you don't get to put on any security tools at all. That's Apple's plan. There's no malware. You don't need any. There's no firewall you can get, nothing. Then if you want all that junk, you have to jailbreak your phone, which is almost impossible these days. If you want that stuff, you buy Android. The whole point of iOS is to be you're getting just access to a limited set of things which people want, and it all works very well and it's all very secure because you don't have the option of doing anything else. It's like a little kid playing in a walled garden with your parents watching over to make sure you're not doing anything naughty. And that's what most people want. They just want their phone to work. They don't care if it can't do exotic things like see the raw packets.
Yeah, but you will be able to see all the traffic that goes from like cell phone via Wi-Fi networks, right?
Well, you could sniff it with something else, like a Windows machine, but you can't sniff it on your phone. Yeah. That's right. All right, then you got consoles, which give you some kind of Snort-like experience, or Splunk-like experience. That's the idea. Somehow let you graphically see the data, and we'll play with these and see how much good we can get out of them. A variety of these, Snorby is one of the tools they talk about in the textbook that they've already given up on. They removed, the book was based on the 2012 version of Security Onion, and the current version is based on 2014 Ubuntu. And in the intervening 2 years, they abandoned Snorby. So the Snorby quit being developed, and they decided it's too old and useless. And I see that happen to a lot of these tools. I mean, the same thing's true of in general open source forensic tools. There are dozens of them, but they really are just one guy made the tool for a few years, he updates it, a few years later he wanders off, and it just becomes old and abandoned. That's why, you know, people pay a lot of money for commercial tools, so that won't happen. All right, then you got data collection tools, Argus Server. We'll see dealing with that today. Netsniff, PRADS, Snort, Suricata, and Bro. And the big winners here are Snort and Bro. Snort and Bro are not going anywhere anytime soon either. Those are really famous tools, have been around for years, and everybody respects them greatly. So the other ones I don't know that much about, but we'll play with them a bit.
Suricata is pretty popular too.
Yeah. I mean, this category, I think there's not so much obsolescence going on. All right, so Argus Server and PRADS store their own form of session data. They are not storing PCAP files. They're storing some kind of summary of the flow. And Argus in particular has a proprietary binary format, which is pretty annoying. But that's the way it is. And PRADS has some kind of data stored that you're supposed to read through a console. So we'll play with that in a future class. But Argus we'll play with a bit tonight. Netsniff-ng is like TCP dump. It just gets all the PCAPs and saves them somewhere. Snort and Suricata are intrusion detection systems. So in addition to recording the data, they compare it to a list of known attack signatures and then send alerts like an antivirus. So that's important, and people value that quite a bit. And Bro is sort of the next generation IDS. I've been to several talks at UC Berkeley about this. Came from UC Berkeley, Lawrence Livermore Lab, I think, and they're very proud of it. It is just the next generation IDS. It monitors the traffic, it finds out who's sending attacks, it blocks them for a period of time, and it does. They say they don't have any static firewall rules at all on the network that they protect them with Bro. It's all dynamic, and it's very advanced. Until recently, it was considered essentially impossible for anybody to configure and use except the developers. But we're going to play with it a bit. We'll see it go. Security Onion is by far the easiest way to use Bro. If you've already got it, it's already running. It comes built into Security Onion, which is a good start. And all you have to do is learn how to see the results and use it, and we'll get to that in a later chapter. Then there's middleware. These are things that go between the data collection and data presentation tools to connect them together. Pulled pork, which I assume must have something to do with Snort, manages IDS rules. There's quite a few pig-oriented Snort add-ons, and there's also a Snort attack tool called Mucus. So you can tell with a name like that, they inspire the open source community to have similar related names. Then there's Barnyard for alerts, and CapMe to manage PCAP access. And again, we'll play with them in the future, but these are all tools that sit between the collector and the displayer. All right, and then there's SGUIL, which I'm going to find out what it is, but I assume it's probably Squil, but I don't know. These are agents used by SGUIL to collect the data. PCAP agent, Snort agent, and then it moves it to tools that we might be more familiar with, like Apache Web Server, MySQL Database, and Sphinx Indexer, which I've never used, but it's running. You'll see it, it's running on Security Onion. So we'll play with some of these things, and you see the large suite of tools used by the open source community to do all this stuff. And then there are integrating tools, one called OSSec, which is a host-based IDS, not a network-based IDS. So it monitors the traffic coming into one host, and syslog-ng, which will aggregate log messages. So this is the grand diagram of it all. You've got collection tools down here sniffing the network and then saving PCAPs or some other kind of summary data like session data. Then you got things in the middle that just collect the data here and somehow reformat it and move it on. And then you got things up here that try to present it in some pretty form so the user can use it, like Wireshark and Network Miner and ELSA. These are, and that's sort of like the layers of the TCP IP model. You know, you got the details down here, you got the connector, and then up here is the part that the human can see something hopefully pretty and informative. All right. So TCP dump is where it all starts. You can analyze things with TCP dump, but it's mainly used just to capture things. It's not running by default in Security Onion because all those other things are running, and they're storing all kinds of records of all the packets in the NSM directory /NSM, but you do have TCP dump and you can run it to make yet another file on the side for your own purposes, and that's what I have you doing in this project just so we don't have to dig through gigabytes of data. So you can use it to analyze. This is where all the standard automatic tools in Security Onion are putting stuff. NSM, it's Network Security Monitoring is the main folder, and then sensor data. The name of your sensor, which is something like the SO-Security Onion-ETH0. And then you have daily logs in there, which will grow. So if you have a Security Onion box in a virtual machine, you can't just turn it on and leave it on forever. It will fill up the hard drive with data. All right. I'm not quite sure what will happen. It probably is smart enough to delete stuff, but I'm not really sure. Anyway, one fun thing about TCP dump is you have to use sudo. You can't sniff anything without superuser privileges, which is kind of disturbing. But anyway, you can sniff on ETH0, and then you get this traditional stuff, and you should know how to read this stuff. This is the one-liners. It's sort of like what you see at the top of Wireshark. So every one line is one packet. So you have a timestamp, then you have a source, IP address, and port number going to a destination, IP address and port number here, and then you have some information about it here. If you don't put -n in the command line, it will attempt to resolve the numbers into alphabetic names, like MDNS here and domain for there and so on, and it leaves these 50669 and 50314 alone because it can't figure out what's on those high-numbered ports. And then it tries to turn things here into domain names. If you don't want to doing all those domain name lookups, you put a -n in it, and then you get just the numbers. So here's some useful switches. -n will just not look up names and show you raw numbers. -s will adjust the snap length. By default, TCP dump does not examine the whole packet. It only looks at the first 68 bytes for IP version 4 and some longer number, I think 96 for IP version 6, because all it wants is enough information to make that summary line, which is the source address and port, the destination address and port, and a little bit about the protocol, not the whole packet. You can limit how many packets it'll collect before stopping with -c. You can use -X to print out all the details, all the bytes in hex and in ASCII, so you can see them. And you can use -W to put a PCAP out, which is usually what you want to do. For simple tests, like when I'm having trouble accessing a server, I'll just run TCP dump directly and then try to ping it and connect to it and see if the packets are getting there. That's just a way to see if the networking is working or if the firewall's on. But for anything of any size or duration, you pretty much have to throw it in a PCAP.
I saw that to get ASCII and hex, you have to do -XX, no?
In the book, they use 2 X's. I always use just 1. Oh, yeah. I imagine there's probably some difference.
Maybe they change it on the way.
Yeah, I know in the book they had 2. Anyway, here's what I did. TCP dump -0 -NX. And now you get the usual summary, which is here, timestamp, IP address, port number, another IP address, another port number, and then the summary. And then you get just what you'd see at the bottom of Wireshark. You get byte by byte hexadecimal values, and on the right, ASCII. So all the information is contained there in that format. This is the top pane of Wireshark and the bottom, but not the middle.
Isn't Wireshark or Ethereal used to leave out some of the encapsulation headers on?
It has different panes. The bottom pane has every bit in hex. The top pane has just a one-liner summary, and the middle pane has these fields you can expand and contract. So you can see the whole thing, or just layer 2, or just layer 3, or just layer 7.
You sure Wireshark has all the headers?
It has everything except for wireless networks, it doesn't have the raw layer 1 radio tap header unless you change it to promiscuous mode, and then it even has that.
Okay.
Yeah, it's these days, Wireshark is, Ethereum may not have, but Wireshark is actually very advanced now. Everything's in Wireshark. The only thing wrong with Wireshark is it's a lot of burden on the system to run all those graphics, and it's a GUI tool, so you can't really automate it, and it's a vulnerability when sniffing raw data because you're using all these. That's the only thing. But it's very, very popular to analyze a trace and see what you've got there. It's often the most efficient way to find something somebody was downloading and things like that. So you can find things here. Here's what a DNS query and reply looks like. It's going up to port 53. And here's a question with a question mark asking for the A record, asking for the quad A record, and here's the answers. All right. So that's what DNS looks like. Here's the TCP handshake. One thing that always struck me as annoying about this is they don't use A for ACK. They use dot for ACK.
Yeah.
Which always confused. So you send a SYN, you get back a SYN ACK, then you send an ACK. That's the TCP handshake. I don't know why they did that. They did not ask me. All right. Now you can have capture filters. Capture filters, it's important to know the difference between capture filters and display filters. If you go in Wireshark and type something in the filter bar, that's a display filter. So if you have 1,000 packets and you filter for just DNS, you might have only 10 packets, but all the rest are still in the file. It's just they don't show them on the screen. But a capture filter actually stops and only captures certain traffic. Now, when I was doing the packet hacking contest at DEF CON, this was a big deal because they had a lot of traffic flowing for quite a while, and you have to catch it all. If you put it all in one file, it's too big to handle. So I put up several TCP dump sessions, one having just certain ports, one having another port, one having everything else, to split it up in certain files right from the start. And that's what you usually do. That's what capture filters do, and it's in the Berkeley packet format. The same thing's true in Wireshark. You can actually use capture filters there, although they're not commonly used. And then you actually will ignore some of the traffic on the wire and only save the ones that match the filter, so it will save space on your disk. So that's the game here. If you just put names there, it'll take only them. So if you put ICMP, it'll keep only the ICMP packets. This will go for a UCP or TCP port. Here you can specify TCP and port 443, and you can use the man page to get all the options, and there's lots of options for these filters. You can even go to every single bit or every single byte and specify binary patterns to match to get exotic things like IPv6 router advertisements if there's not a alphabetic phrase that stands for that. So here's some common examples. You specify the host, it'll give you source or destination, or you can specify source host or dest host if you want just traffic to or from something. And you can also refer to networks with the network identifier there. So it's pretty smart. So here's how you get only ICMP replies. You'd have ICMP type equals ICMP echo reply and a destination host. So it'll be just the replies going to one host. You know, you can filter it any way you like, and it will not capture any other packets. So it'll make this file called ICMP.pcap that includes nothing except the packets that obey that rule. You can read a lot of files. So you can use it to analyze files. So it's TCP dump on number, counting 1, and you're going to find the logs. This is this backtick thing. So it's going to do a find in this directory to find all the files that match this pattern. So those are all the daily log files. And for each one of them, it's going to put it here in $I because you specified that up here for I in here. So this is I in a set of values, which is going to be all the file names. So I is going to represent one file name at a time and go here. So TCP dump will read that file and then pick one packet out involving 8.8.8 in TCP and print it out. That's the game here. The thing that's kind of funny to me is I don't think there'll be any packets going to 8.8.8 that are TCP. That's a DNS server. It's probably only got UDP packets going to it, so I'm not quite sure what the point of this was. But anyway, it shows you the syntax for something where you want to loop through a whole set of files and then pass it through some kind of filter. So I got a few cahoots about that stuff. All right. So I'll wait another 5 seconds, see if anybody more is coming. All right. 5 questions. Okay, which tool uses a proprietary binary format? All right, that's Argus. Okay. Good. Which one is a NIDS? All right, Suricata. A lot of jumps all over the place there, but that's what it is. All right. Which one is middleware? Pulled pork, good. It's a good name. It makes a statement. So, what do you do if you put minus C100 in TCP dump? All right, that's it. Capture 100 packets. Good. And what about minus X? Capital X. Prints out all the bytes in hex and ASCII. All right. Once again, they don't let you see who won. My system doesn't quite get along with it, but it's high, I guess, is a winner. This whole system is kind of, okay. So high and RTM and me, all right. So Dumpcap and Tshark. I mentioned before, these are two tools that go together. Dumpcap comes with Wireshark. Wireshark is a GUI tool, and they give you some command line tools packaged with it. All right, Tshark can analyze traffic. It's much friendlier than TCP dump and much more familiar for people who use Wireshark. It uses a similar syntax, a more human readable. So like TCP dump, you have to run Tshark as root if you want to sniff anything. And if you do, like Wireshark, it will give you an error message saying quit running this as root, which I must say always frustrated me in the past. I mean, how am I supposed to get anything done without running it as root? But the idea is you're not really supposed to be capturing stuff with Wireshark or TCP dump. You're supposed to capture it with Dumpcap and then analyze it later with these tools, which I never knew. I just said, well, that's another annoying message I click through every time. So if you do run it, then you'll see results here which are really very much like what you see from TCP dump. There's a timestamp, then a source to a destination, then the protocol number. They don't put the port numbers right there, but it's pretty much like what you see at the top of Wireshark. One interesting thing is, like Wireshark, the time is not a full timestamp. It doesn't have the date and the number of seconds. It just starts with the first packet at time 0 and then gives you the number of seconds of elapsed time, which is shorter and more convenient most of the time. So you can use the same Berkeley packet filter if you want to. With minus F, you can have ICMP and host number and the usual stuff there to limit what packets will be captured. If you run it as root, you don't have privileges to write to your home directory, which is kind of screwy, and you got to write to /temp, but you're not supposed to be doing that anyway. Dumpcap also captures whole packets by default, unlike TCP dump, where you'd have to specify the snap length. So this is sudo dumpcap on interface eth1, capture 2 packets, write it to this file in the temp directory, and use this filter in the BPF format. So it'll capture only the packets that match that condition. All right, now this is not what you're supposed to do. Sudo dumpcat, you're supposed to reconfigure your Wireshark. If you try to run dumpcap without elevated privileges, it will say, I can't do it. You don't have permission to capture on that device. So this unfriendly command is how you fix it. You reconfigure Wireshark-common. That will pop up a box And this gives you an automated script which will create another user group with the right to read packets and then add the Wireshark user to that group. So now, after you do that, you can now run Dumpcap without administrative privileges. Dumpcap -IE0, it'll start sniffing. So that's kind of fun. If you don't tell it what to do with the packets, it'll put them in a temp folder. All right. And this is what I had to do. Oh, that's right. After you do that script, you have to execute this command and then reboot. That's what adds it to the Wireshark group. That command creates a Wireshark group that's allowed to sniff without being root, and then you have to add your current user, which for me is SO, to the Wireshark group. And then you have to log out and log in again or reboot. All right, so when you're done, now if I do some pings, you can catch them with Dumpcap without administrator privileges. You can do Dumpcap capture 4 packets on ETH0 without changing the numbers to names, writing it to a file called ICMP.pcap, and keeping only the ICMPs. So it'll show them going by and write them to a file. So you get a little PCAP that contains a few pings. All right, now you can analyze that saved packet with Tshark without administrative privileges, and that's what you're supposed to do. So you read -R, ICMP.pcap will read it and print out the summary. And if you use -TAD, you will get full TCP type timestamps in case you care. Which is, you know, if you're just trying to detect whether there's an attack or something in one packet stream or what file was downloaded, you don't care, but usually you're trying to analyze an incident and you have other logs. And so you have to find out, you do need that timestamp because you need to know they sent in the attack here, then this server got hacked, then this antivirus went off, then the data started leaving, and you've got to line it all up. All right. You got display filters in Tshark. In addition to caption filters, you can use -Y to show them. And in your book, they tell you to use a -R, but that is now deprecated. You're supposed to use -Y. If you use -R, it will just tell you to knock it off. Anyway, so you can read that file, and then you can have a display filter. So I only want to see, I think, the echo replies with ICMP type equals 0. Yeah. And now, even though that thing has 2 requests and 2 replies, I'll only see the replies. So you can filter it for anything you want. You can use -V for the full protocol decode, and you'll see all the data that Wireshark would have shown you, and -X if you want the hex and ASCII. So if you run VX, and remember in Linux you can just ram these things together with 1 dash, but if there's one of them that needs a parameter, you have to put it last. So V and X just turn on the full packet logging with the binary, and then R reads that file. So you get page after page of data, and this is exactly the kind of stuff you see in Wireshark. You see 98 bytes on the wire, the layer 1 information, then you see the layer 2 information here with the Ethernet addresses, then you see the layer 3 information with the IP addresses and all the fields spelled out. Then you see the layer 7 information, which is ICMP with all the data, and then you get everything in raw hex and ASCII. That's all the data Wireshark would have put in the middle pane if you totally expanded it, and the bottom pane. And I think you even have the top pane right at the top. That doesn't seem to show up here. Looks like you're missing the one-liner with this display. But anyway, you're getting all the details. So this is something I've often done, and then I dump this in a file, and then I search through the file for a string, trying to find something like a flag or a file name or something being sent by. All right. So you can filter it. You can just do -Y HTTP, and that will have the same effect as typing HTTP in the green filter bar in Wireshark. It will take the input, which in here is a PCAP with 200 bytes, and it will pick out just the HTTP, which is just 4 lines of data. All right. And you can use, this is the analogous one from before. We're going to loop through all these files with the same procedure. So you have a find command with type F that will find all the files in some directory. You put it in these backticks, which I must say are not a wise thing, those crazy backticks. It's probably much better to use $ open parentheses and close parentheses. It's easier to read and stuff. But anyway, old Linux gurus that really think it matters whether you have 3 keystrokes instead of 2 get used to using this crazy backtick thing. Anyway, that will execute first inside the backtick, and the result of it will be used. So you'll have 4i in a list of files, And then for each one, you'll echo the file name, so I know which file it is, and then run Tshark, reading that file, and with a packet filter, which would now be minus, not minus R, but minus something else, minus Y. And here look for HTTP user agent contains curl and request method equals get. And so you go, now it's going to find just the one method that used curl to fetch a page. And it tells you the name of the file in which that happened. And here's worth mentioning, I mentioned before, when you don't do anything in Security Onion but turn it on, it automatically starts stiffing the network and saving everything, and it puts it here. NSM sensor data, name of your file, name of the network card, daily logs, then a date, and then down here go a lot of logs. So this particular one is hunting through Snort logs.
What does a double equal sign mean? If?
No, that means equal. That's how you write. That's not the Berkeley packet format, but it's the Wireshark display filter format. Name equals value. And then you can do bang equals for not equals, and greater than equals and less than equals and all that jazz. All right, you can search for a range of IP addresses. So you can search for IP destination greater than 8800 and less than 8899, and you'll get 8888 and 8844. So that's an option if you don't want to just go for a whole subnet. And all right, so that's the joy of TCP dumping. I could show it live, but I don't think it's really worth it. It's really pretty simple. And you'll go through it in the project. I gave you, of course, a project where you practice all these things. Argus is kind of interesting and new. And I must say, one thing about Argus is when my box, Argus was turned off. It wasn't running. So this is probably the first thing to know. NSM sensor PS status. This is your best friend. Before you struggle with your setup, so I've got Security Onion running here. Whoops, better spell it right or I'm not getting in. Now I could control it by logging in and using the desktop, but that's for amateurs. You should probably be using SSH. SSH is your best friend. And it looks like I've lost my connection, but that's all right, I can make another. It's 196. Okay, so it's SSH, Security Onion at 172.16.1.196, I think. Nope, spelled it wrong. Okay, and SO is the password, which is not secure but convenient, and that's all I care about right now. Okay, now, I'm in here. I could try figure out what's going on with things like PS. They'll show all the processes and stuff. But what's probably better is to just do this, NSM sensor PS-status. It requires elevation, and now this is a special Security Onion command that tells me if all the junk that Security Onion should be running is running. And you'll see now it's Netsniff-ng, it's running Argus, it's running Snort, it's running SGUIL, and Barnyard. And all of them are okay. Now, when I had my freshly installed Security Onion, the way you did in Project 1 or 2, Argus did not have the OK. And so I went in the book and I found out how to turn it on, and I discovered it was just turned off by default. And I don't know why. There may be some blog post from the makers of Security Onion showing why it's turned off by default. So if I put in the project, you will probably have to do this. There are some config files that are plain text files, and they have Argus enabled equals no. And if they do, you have to change it into Argus enabled equals yes. Not particularly baffling, but I wouldn't have known what directory to look in without the instructions. And then you can just restart. This is handy. You can just restart everything that should be going. NSM restart. That will start all the security monitoring that's turned on by default, which is those 5 or 6 things. So that's good, clean fun. Whenever you get annoyed, you can just restart it all. I don't know about you, but my Security Onion thing keeps popping up boxes telling me there's an error, and I should report it to Ubuntu. So, like I say, these things are probably the world's best advertisement for Splunk. You're using all this open source stuff, a bunch of the options don't work, a bunch of the instructions are wrong, and then it crashes a lot. And your boss is saying, why don't we just pay what it costs to get Splunk?
Well,
Which is a pretty unanswerable argument, yeah.
I think like to modify bro rules, you have to have specific knowledge, and those are not cheap. I think like bro scripting course costs like 1,500 or something like that.
Yeah, that's right. It's an important point. I'm just repeating it for the remote viewers that the bro is not easy. Bro is famously difficult to use, and you'd have to pay money to take a course to learn how to write bro scripts. That's an issue. And a lot of these tools are pretty burdensome to the machine. You may remember you needed 3 gigabytes to even run it. So it's network security monitoring is a pretty high processor job. And doing it in one virtual machine is only for testing and learning, not very practical. Anyway, you can stop and start Argus this way if you like, with just that one entry only with NSM sensor PS stop and start, or you can just restart them all with this sudo. And you can restart services and it will not mess up the files in progress. It'll just continue to append to the log files later. So it's pretty harmless to restart the services, although I would imagine it probably misses a few packets while that's happening. All right, so Argus data is in this binary format. You can go to where it lives, which is here, NSM sensor data, then the name of your machine, the name of your interface, and Argus. And if you look in there, you'll find a log file with the date and the log. And it's not very big. This one's only 10 kilobytes. And that's the point of NetFlow data or session data. You don't store the whole packets, you store some summary line. Now, if you try to view it, it's just unreadable binary, so you have to have a tool to read it. All right, here's a clue, by the way, of how much data it saves. Here's 48 days of data that the author put in. So the full packet caps are 83 gigabytes. But the Argus logs are only 2 gigabytes. So as you'd expect, it's a whole lot smaller and a whole lot faster to search through. But if you need all the details, they are not there. This is super important for incident response, where you need to find something you can find fast that will not drive you mad to tell like whether this box is infected or not. You look for a register key, a log entry. You don't really want a whole hard disk image or anything big and complicated. You need something that you can script and quickly tell, is this box part of the problem or not? All right, so use RA to view the Argus data. That's the client, raw. So it runs like these others. You have raw, then you give it the name of -R and the name of a file to read. You can use -N if you don't want it trying to resolve the names into alphabetic names. And then what's kind of screwy is the switch for filter is just -nothing. When I saw that, I figured it must be a typo. You know, there are standards for Unix switches, and there's a bunch of people that just don't read them, and they write weird tools that use -- instead of dash and stuff like that. Anyway, this is kind of screwy, but that's the way it is. So after that goes your filter, which is the same old BPF thing, TCP and destination port 41. And then you can use -S to specify what fields to display. So it'll show time, address, port, destination address, and so on, if you want to, which is kind of cute. So there's what it looks like if you, here's a very simple one where I just did raw R, just the name of the file, and that's it. And then, because it was too long, I just sent it through more to keep it on the screen, and here's the first few lines. So it gives me a timestamp here, which is the whole, looks like just the time of day, not the date. Then some protocol, source address, source port, and since I didn't put in a -N, it's taking away the numerical source ports and turning them into things like SSH and MDNS and NTP, and then destination port, total packets and total bytes. And that point should remind you what I've been saying. This one line is 6 packets for 616 bytes. In TCP dump, that would be a lot of data. In Argus, it's one line for one flow. And I mentioned that because we're not using it here, but I think the king of this stuff is NetFlow. NetFlow is a Cisco product, and it is used to help ISPs control their customers' usage of the network. So you can ask, how much has this guy been downloading, how many bytes have been on the one protocol, and you can easily put limits on all that and decide if they exceeded their threshold and such. That's what NetFlow is for. It gives you a summary like this of the flows instead of every packet. So you can quickly decide who's doing something bad here and I should choke them off.
Is that what
yeah.
internet service providers used to combat torrent use?
What's that?
Is that what the internet service provider uses to combat like piracy? Like when
well, that's a good question. Whether they use it right now to fight piracy, I would say probably not to fight piracy, because torrent clients have gotten too smart. What they use mostly now is layer 7 firewalls, like the Palo Alto firewall. But NetFlow has been the standard for years as just a way of monitoring traffic. And then you can see what your traffic is doing and see which parts are working, which parts aren't. It's probably not the most effective way to combat abuse, but it is the way to keep your network working by knowing how full it is in various ways. All right, so you can run raw help and get a list of all the switches, which of course is good. I mentioned this crazy nothing switch with just minus. You'll use that all the time. I guess somebody thought saving an extra keystroke was worth breaking the protocols of switches. So here's raw filtered for ICMP. I just tell the file to read, I put a minus, a space, and an ICMP, and now I get only the ICMP packets. All right, and those are ICMP flows. So these first couple are individual packets, but these ones are flows with 2 packets, request and reply combined into one line. And that should introduce you to another fun fact, which is, like all other flow monitors, RAW is not very good at detecting an entire flow. It can easily break up a flow into several chunks by somehow getting confused about where it starts and stops. For example, I'm controlling my security onion through SSH primarily, so I have a lot of data going through SSH. So here's a whole bunch of data from the same source address and source port to the same destination address and the same port, and RAW breaks this up into dozens of lines. 6 packets here, 21 packets there, 90 packets there, because in its wisdom, it regards the transaction as complete when I would say it's not complete. I'm still using it, but it hits something which RAW interpreted as the end of a session. Probably something like a fin, and then like a keep alive, as I paused while in my typing, and so regarded that as a different session. So if you get tired of that nonsense and you just want the bottom line, you use raw cluster. Raw cluster will gather it all. So that previous file that would have had 50 or 100 lines now has just a few lines. And now it tells me my machine on port 22, I talked to it this way and I sent data that way. There's just 2 flows for the whole thing, because I'm only looking at port 22 and I've only got 1 SSH user. So it got it down to just 2 flows. One way and the other way it's not sure about the direction. I don't know why it wasn't able to just call it all one bidirectional flow, but at least it got a whole lot simpler. So if you have something like a command and control server IP address and you just want to know, have they been talking to that IP address or not, this is the kind of thing you do to very quickly get a simple file where it'll be easy to tell, did they talk to this guy or not? And if so, what time did they talk to it? And that's probably all I care about. All right, you can actually count the lines, of course. If you know a bit of Linux, you can pipe this to word count minus L, and that will count the lines of output. So if you run raw on my file, it's got 249 lines of output, but if you run raw cluster, you get 2 lines of output, or 3. And that includes a header line. So that's, of course, why you do it. Raw cluster is real super compact summary. All right, you can also group things by source and destination address, and this will cluster them together. So it'll be even simpler. Now see how that one looks. All right, so without -m, if I run raw cluster on UDP port 53, I see a whole bunch of separate DNS requests with 2 packets in each one, a request, a reply, a request and a reply, because I just did a few digs to get some things here. So that's what I'll see. And it'll just go on, and I have a lot of them. Whole screen's full of it. Every single DNS request and reply, and of course, DNS and ARP are just constantly flying through your network. Every web page you open is another 25 DNS requests. If you put -m in here, where it's going to group it by source address and destination address, then it goes down to just 4 lines. And so I have 4 packets going from this UDP to that server, 4 packets going, I resolved some of my data at this Google server, and some of it at that Google server, and some at the default server, and some at OpenDNS. So I give you just 4 lines because I've really been talking to 4 different servers. And this is 130 packets, so it is many DNS resolutions going to the same server. So I don't have any of those details, but if I'm worried about some kind of attack, like a DNS changer, I can quickly tell here whether it's using the good server or the bad server. And like I say, that's probably all I want to know. I want it to remove all the rest of the details to get down to the point. And down here, I grouped it by just source address, but not destination address. So looks a little different. One thing I see there is destination address 0000, right. So all the destination addresses are rammed together. This is one record for the whole thing. This source sent that many packets, and notice that all you get is the starting time, which is the first packet. Even though this is like 100 DNS requests all staggered in time, it just puts 1 timestamp on it. So, you know, you're losing a lot of information when you summarize down at this level. And here it is sorting on just destination address, which is the same thing as sorting on both in my case, because I only have 1 machine. I'm just sending traffic to and from my security onion machine, but in a real deployment, it would be receiving data from many machines. And there would be something meaningful in varying the source address. All right, here's another example. Use raw cluster. You can specify the source address, and this one's going to specify a source address, a one address, and a whole block of destination address. So you just have source host this and destination net that, and you can put in the /24 to specify any network range you want. And on you go, and UDP and not 53 or 123, so they don't want DNS or NTP, and they don't want this one host in there. It's just an example of a complicated condition. You can make it as long as you want, and this, not that, and this, until you zeroed in on whatever you need. All right, another bunch of coots. See how many remote viewers we got. We got 6, okay, fair enough. That's all I thought. A lot of people would rather not drive here. I hope they're getting some benefit from it, but I certainly understand that there are reasons to not drive to school. I'll wait another 5 seconds. All right, off we go. 5 questions. Hey there. All right, what tool is likely to have vulnerabilities? I see a chat comment. I will look at it after the question's over. Okay, that's Tshark, because it's like Wireshark. It uses the name packet dissectors, and they tend to have just vulnerabilities. Let's see what somebody has to say. I'm in the lab. Okay, fair enough. All right. Well, that's good. That means the lab will be open when it's time for you guys to go. All right. So you did drive to school, but then had to hang out in the lab. That's fine with me. I remember when I saw Stallman's talk, the room was really crowded, and there was like an overflow room with a video recording and a table you could sit at, and you could chat, and it was so much more comfortable than being right in the room. I couldn't understand that. You sit there with a cup of coffee, and you can also make sarcastic remarks without the teacher hearing you, and you know, it could very well be a better experience. Okay, which one gives you your most complete protocol analysis? They had some different music for a while, but it seems to have gone away. I guess they beta tested it. All right, so it's Tshark. I'm surprised people are reluctant to give the same answer twice. You can't be thinking that way. But the Tshark, of course, it's Wireshark. It gives you the most perfect protocol analysis. That's why it's vulnerable. It has thousands of protocol dissectors contributed by the community at large. So it can do everything. It can get into voice calls, just every crazy thing. It can totally understand it and dissect it. All right. What does the -y do? All right, it's a display filter. The same thing you'd put in that green bar at the top of the graphical Wireshark, which is what I love because I've got a bunch of those memorized, and having a command line tool use the same format is very convenient. All right, which tool will show you Argus data? All right, that's Ra. Is Argus some kind of Egyptian god or something? I know Ra is. Anyway. Yeah, anyway, I don't know what I'm sure there's some esoteric reason why this fits some kind of pattern, but anyway, it's Ra to see the Argus data. All right. So what command will show many lines for one conversation? All right, that's Ra. Again, not a popular answer. Ra breaks it up. That's why Ra cluster exists, to solve that problem. All right, well, like I said, I read a clue when people aren't getting it. that's the time to shut up and let you do some hands-on projects. Let me just record the winners. Artyom is a winner twice, and so's AE. No, AE and Kofief. That's a good name. All right. So, hi, me, AE, and Kofief will have to identify themselves. Other than that, I think I'm done. Let me just, somebody had a chat comment. Let's see what they have to say here. Check your email about micro K. I have no idea what that is.
They might talk to each other.
They might, well, that's true. That could be each other. Or else maybe there's something called micro K that's awesome. All right. If I find out about it, I'll put it in the news. Yeah.
Well, I've seen SolarWinds working in conjunction with Splunk.
SolarWinds, and I know SolarWinds makes a bunch of things. Which one?
I mean, they have the IT management. They monitor not just the network bandwidth and whatnot, the application level, the server, as well as databases.
Wow, so it's SolarWinds, what's the name of the product? Is that just it?
Yeah.
Oh, I haven't used it.
I'm just curious.
Is it commercial?
Commercial, yes.
Well, I'll have to look into it. If you can demonstrate it or something, that'd be great. But I'll try and, remind me, I'll try and look at it. I don't know about it. Anyway, I suppose I might as well mention, you've got another homework assignment. I just put it up today, which is pretty predictable. It's just everything we did in lecture. So you'll get practice doing all this junk if you do project 5. You just go through, capture some stuff, filter it with all these tools, and see it go. And like I say, in my opinion, the most important thing you can do is 3, 4, and 3x. Learn Splunk. Splunk is hard to use, and you should learn it. This is your chance. And everybody's going to want to know in the real world if you can run Splunk.
Yeah, just recently someone was hiring like 30 people for the security operations center, and it's like entry-level position, and said the only thing that you need to know is Splunk.
Yeah,
if you get that knowledge, you got the job.
Absolutely. And I went to the Splunk convention. It's huge. They're growing like crazy. They're rich. They have training and certification and everything else. So Splunk, check out the Splunk. Splunk is your best friend. I think Splunk will do you a lot more good on your resume than Security Onion.
For sure.
Okay.